Hi, so welcome to lesson number 1, module 8 of the Big Data and Hadoop developer course. So in this lesson, we will be introducing Sqoop. So before we proceed with the lesson, let's have a quick recap of the previous module. So in the previous module, we had a detailed discussion about the data warehousing tool called Hive. We saw the architecture of Hive, and we also had a look at the primitive and complex data types in Hive. Then we started working with Hive and we created tables. We did join, we interacted with the Hive query language. We also understood the advanced concepts such as partitions and bucketing. And then we learned what is the difference between managed and external table. We learned how to create a Hive script and advanced topics such as user-defined functions and indexes. So in this lesson, we will understand the need of Sqoop and the basic concept of Sqoop. So just imagine that you're working in a very large big data project where your client is one of the largest retail store present in the country. So in this case, when you want to load data into Hadoop from your client's ecosystem, there might be a mixture of structured as well as unstructured data. Now we know that big data usually accounts for unstructured data. However, since we were working with structured data for so long, many organizations will already have a traditional RDBMS in place and tons of tables inside the same. So when you bring all this into a Hadoop ecosystem, the real problem that you are going to have is how do you copy the tables or the database from the RDBMS into Hadoop? Now, you can definitely write a script to do so, but that will be time consuming and ineffective. You can also take a dump of the entire database from an RDBMS such as Oracle and try to manually copy that using the Hadoop copy command. But in all these situations, we should ensure that the data schema is preserved. For example, if you are copying a table, the table should remain intact as it comes to Hadoop. And also, we might need fine-grained control on the transfer of the data. Now, what I mean by fine-grained control is that maybe you have to use a condition while transferring the data. Maybe the organization has a very big table in Oracle. You are interested only to import maybe a couple of rows or couple of columns. So how can you selectively import the data from an RDBMS into Hadoop without compromising the schema? That was the real challenge we had, and the tool Sqoop is here to help us with that. So if you ask me what is Sqoop, it is a Hadoop ecosystem tool which allows seamless connectivity between RDBMS and Hadoop. That means it can copy your tables and database from RDBMS to Hadoop and vice versa. Now, if you look at the different ways to copy the data into Hadoop, there are three major ways. Well, there are many ways, in fact, available, but there are three popular ways, I should say. So one of the way is the manual copy command. Now, we are aware of that. If you are having the file present in the local file system, you can simply do a hdfs dfs -put command to manually upload the file. The second way is using a tool called Flume. Now we will be having a detailed discussion about Flume in the next module. What Flume basically does is that it allows you to copy streaming data such as log files, tweets, etc. on a continuous form to Hadoop. Now the third way is what we are discussing is called Sqoop. While Sqoop allows you to copy the data from an RDBMS into Hadoop. Now, why this is so important? Because you should know which tool to use in which situation. So if you're having, if your task is to collect web logs, the log files that are generated by a web server time and again every day, then well, I should say Sqoop is not your best friend. Go ahead with Flume. Or if you have 1 terabyte of data, which is a fixed file, and if you want to copy that, will go ahead and manually copy that. However, whenever there is a presence of RDBMS and you want to copy the data, then tool Sqoop is the best one. So here we can have a quick look at some of the use cases of Sqoop. In fact, there are a lot of companies who effectively use Sqoop. One such example is the online coupon company called coupons.com. Now, coupons use Sqoop to exchange data between Hadoop and the IBM Netezza data warehousing application. Now, the organization use this tool to transfer data, and then they can query the structured data from their data warehouse, and they can even pipe the result into Hadoop using Sqoop. Now, the second example would be the company called Apollo Group, who is into education. Now, they use the software not only to extract data from databases, but to inject the result from Hadoop just back into relational database. Now, that is another very interesting aspect of Sqoop. Many times, your organizations might be using traditional business analytics tools which will run only on RDBMS or all app systems. Now, in that case, if let's say you are doing some analysis inside Hadoop and you get a final result in the structured format, that has to be present inside the RDBMS. So Sqoop very well allows you to get this from the Hadoop ecosystem back to RDBMS as well. So what exactly is Sqoop? It is a tool designed to efficiently transfer bulk data between Hadoop and structured data stores such as RDBMS. Sqoop imports and exports data between external structured data store and HDFS. Now, when you say a Sqoop import, that means you are copying data from RDBMS to Hadoop. When you say Sqoop export, that means you are copying data from Hadoop to RDBMS. Now, the advantage of Sqoop is that it really works very well with most of the RDBMS available in the world, such as Teradata, Netezza, Oracle, MySQL, Postgres, etc., etc. So you will not find it difficult to implement Sqoop because most of the organizations will be having one or the other RDBMS that I have just mentioned, and Sqoop allows connectors to connect to them and directly import the data. Now, like we have discussed before, the need for Sqoop, many organizations deploy Hadoop for analytics, but that really requires the structured data to be copied into Hadoop, and Sqoop does this task very efficiently. So to wrap up, in this particular lesson, we have learned about the need for Sqoop, the basic concepts of Sqoop. That's all for this lesson.